Electrical bonding and grounding are crucial safety measures in electrical systems. They work together, but they are distinct concepts with different purposes. Grounding provides a path for fault current to return to the source, allowing overcurrent devices like circuit breakers or fuses to operate and clear the fault. Bonding, on the other hand, connects whole non-current carrying metal parts together to create an equipotential plane, minimizing voltage differences and preventing electric shock. Let's start with grounding. The purpose of grounding is to provide a low impedance path for fault current. This path ensures that if a fault occurs, such as a live wire coming into contact with a metal enclosure, the resulting high current will quickly trip the overcurrent protection device. There are two main types of grounding systems: equipment grounding and system grounding. System grounding refers to the grounding of the neutral point of the electrical supply, such as the neutral conductor in a 120/240 volt split-phase system or the neutral point of a transformer. This grounding provides a stable reference point for the voltage and helps to limit voltage surges. Equipment grounding, on the other hand, involves connecting all non-current carrying metal parts of electrical equipment to ground. This includes things like metal enclosures, conduit, and junction boxes. The equipment grounding conductor, often a green or bare wire, provides a path for fault current back to the source, tripping the overcurrent device. Now let's discuss bonding. Bonding is the practice of connecting all non-current carrying metal parts together to create an equipotential plane. This means that all bonded parts are at approximately the same electrical potential. The purpose of bonding is to minimize voltage differences between metal parts, reducing the risk of electric shock if someone comes into contact with two different metal surfaces. Bonding is particularly important in areas where people are likely to come into contact with metal objects, such as bathrooms, kitchens, and outdoor areas. Bonding is achieved by using bonding jumpers or conductors to connect metal parts together. For example, metal water pipes, gas pipes, and metal enclosures are typically bonded together to create a continuous bonding system. In addition to protecting against electric shock, bonding also helps to reduce electromagnetic interference, or EMI. By creating an equipotential plane, bonding minimizes the potential for stray currents to flow through metal objects, which can generate EMI. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding in electrical systems. It is important to follow these requirements to ensure the safety and proper functioning of the electrical system. Let's look at some specific examples of grounding and bonding applications. In a residential electrical panel, the neutral conductor is typically bonded to the metal enclosure of the panel. This bonding provides a path for fault current to return to the source and trip the main breaker. The equipment grounding conductors from all circuits in the house are also connected to the grounding busbar in the panel, which is then connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod driven into the earth or a metal water pipe that is in direct contact with the earth for at least 10 feet. In a commercial building, the grounding and bonding requirements are often more complex. The NEC requires that all metal raceways, cable trays, and other metal enclosures be bonded together to create a continuous grounding system. In addition, metal water pipes, gas pipes, and structural steel are typically bonded to the grounding system. The size of the grounding and bonding conductors is determined by the size of the overcurrent protection device in this circuit. The NEC provides tables that specify the minimum size of the grounding and bonding conductors based on the ampere rating of the circuit breaker or fuse. Proper installation of grounding and bonding systems is essential for safety. All connections must be tight and secure to ensure a low impedance path for fault current. The grounding and bonding conductors must be protected from damage and corrosion. It is important to periodically inspect the grounding and bonding system to ensure that it is in good condition. Any loose or corroded connections should be repaired or replaced immediately. In addition to the NEC requirements, there may be local codes or regulations that apply to grounding and bonding in a particular area. It is important to check with the local electrical inspector to ensure that the electrical system complies with all applicable codes and regulations. Here are some common misconceptions about grounding and bonding. Firstly, grounding is not the same as bonding. Grounding provides a path for fault current, while bonding creates an equipotential plane. Secondly, grounding is not a substitute for overcurrent protection. Grounding works in conjunction with circuit breakers or fuses to protect against electrical hazards. Thirdly, grounding does not prevent electric shock in all cases. If someone comes into contact with a live wire and ground at the same time, they can still receive an electric shock. However, grounding reduces the risk of electric shock by providing a low impedance path for fault current. Fourthly, all electrical equipment must be properly grounded. This includes everything from large appliances to small power tools. Ungrounded equipment can pose a serious electrical hazard. Fifthly, it is important to use the correct size grounding and bonding conductors. Undersized conductors can limit the flow of fault current and prevent the overcurrent protection device from operating properly. Sixthly, grounding and bonding systems must be properly maintained. Loose or corroded connections can compromise the effectiveness of the system. Seventhly, do not rely on the neutral conductor for grounding purposes. The neutral conductor is designed to carry normal load current, not fault current. Using the neutral conductor for grounding can create a dangerous situation. Eighthly, ground fault circuit interrupters or GFCIs provide additional protection against electric shock. GFCIs detect small amounts of current leakage to ground and quickly interrupt the circuit, preventing serious injury. Ninthly, surge protection devices or SPD can help protect electrical equipment from voltage surges caused by lightning or other sources. SPD divert the surge current to ground, preventing damage to sensitive electronic equipment. Tenthly, always consult with a qualified electrician when working with electrical systems. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to do the job safely. In summary, electrical bonding and grounding are critical safety measures that protect people and equipment from electrical hazards. Grounding provides a path for fault current, while bonding creates an equipotential plane. It is important to follow the NEC requirements and consult with a qualified electrician to ensure that the electrical system is properly grounded and bonded. Remember, grounding is about providing a safe path for fault current to return to the source, trapping the overcurrent device and clearing the fault. Bonding focuses on minimizing voltage differences between metal parts, reducing the risk of electric shock. Both are essential for a safe electrical installation. Understanding the difference and ensuring proper installation and maintenance of both grounding and bonding systems is paramount for electrical safety. Remember to always consult the NEC and qualified professionals for specific applications and compliance with local codes. Grounding electrode conductors connect the grounding system to the earth, providing a reference point. These conductors must be sized appropriately and protected from damage. Bonding jumpers are used to connect metal parts together, ensuring electrical continuity. These jumpers must be properly installed and secured. Regular inspections of grounding and bonding systems are essential to identify and correct any issues. Look for loose connections, corrosion, and damage to conductors. In addition to the basic principles, there are some advanced concepts related to grounding and bonding. Isolated ground systems are used in sensitive electronic equipment to minimize noise and interference. These systems provide a separate grounding path for the equipment, isolated from the building's main grounding system. Equipotential bonding is used in swimming pools and other wet locations to minimize the risk of electric shock. This involves bonding all metal parts within the pool area together, creating an equipotential plane. Lightning protection systems are used to protect buildings from lightning strikes. These systems provide a path for lightning current to ground, preventing damage to the building and its contents. When working with electrical systems, it is important to always follow safe work practices. Wear appropriate personal protective equipment or PPE, such as safety glasses and gloves. De-energize the circuit before working on it and verify that it is de-energized using a voltage tester. Lockout and tag-out procedures should be followed to prevent accidental energization of the circuit. Never work on electrical systems while standing in water or on a wet surface. Avoid working alone, and always have someone nearby who can assist in case of an emergency. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Remember, electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. The goal of grounding and bonding is to create a safe environment by minimizing the risk of electrical shock and fire. By understanding the principles of grounding and bonding and following safe work practices, you can help to ensure the safety of yourself, your family, and your community. Always remember that electrical work should be performed by qualified individuals who understand the risks and safety precautions involved. This narration provides a comprehensive overview of electrical bonding and grounding, covering the basic principles, applications, and safety considerations. It is intended to be used as a resource for learning about these important topics and should not be used as a substitute for professional advice.